Right. Good morning, everybody. So, actually, at present, we are discussing about the uh, single node architecture. Single node architecture. The single node for the wireless sensor network point of view, uh, sensors are important. Then, what are the parts are added to the a single sensor that is called as a node. Okay, so sensor is a main part, and along with what are the main parts are required. This is already discussed. Just I want to recollect the previous information. So this is the main parts added to the sensor network. So this is called the single node. So main thing for any sensor is a main part. Actuators is a main part. So this is the heart of your node, and this data should be processed by the controller. So already said that why we are using controller, because low data rate and low power. That's why controller here uses. Example is a HTML. Okay, I think 8 mega, 8 mil. These are all the microcontrollers uses in the sensor network. Next, for the any process, because for any coding, we require some memory. So actually, controller do not have sufficient memory. That's why we should exchange some memory. So that memory may be the EPROM. So EPROM stores the coding permanently. So whenever a power loss, then information should be stored into the cache memory. That is called as a EPROM or flash memory. Next is the, so okay, up to now it is good, but what is the purpose? You want to communicate. That's why communicate device is also important. Suppose, okay, good. Suppose how they are working. So because if there is a power available, then we should. If there is no power, then what is the use? There is nothing use. So that's why power supply is also important. Power supply is also important. So these five are important: sensors, actuators, memory, controller, and communicating device, and power supply. And power supply. Clear? Right. For each and every time I'm going to admit is very difficult. So please log in within the time. Okay. Next. Already discussed in the previous one. So this is for the controller. What is the controller we are using? The Texas Instrument MSP 430 or 8 mega. So this is, you already use the Arduino. Okay. So next to the communicating devices. The communicating devices can operate in a half duplex. Why half duplex? Because uh, the communicating device can communicate in transmission as well as receiving point of view, but not simultaneously. So for this purpose, we are utilizing the uh, transceiver purpose, but half duplex. So either transmission or receiving should be takes place. Once one operation is executed, the memory should be wiped. Next. Uh, What are the transceiver characteristics? Transceiver characteristics. Number one, the first thing is that we are using the wireless sensor networks. We are using the wireless sensor networks. So for the wireless sensor networks, you already know that the structure is there. So bottom is the physical medium, and above that there is a MAC medium. So medium access control. That's why the first transceiver purpose is you should our provide services to the MAC layer. Provide to the MAC layer. Next is the, so what are the characteristics? Power consumption. What is the power required for the transmission of the data? Transmission of the data. What is the data for single bit? For single bit. Okay, all right. Next is the carrier frequency and multiple channels. So why we are using carrier frequency and multiple channels? Because different applications, single sensor cannot activate. There are two different things are there. Number one, if it is working in different purpose, then each and every application can utilize a separate frequency. Or second thing, if you are if suppose there is a congestion, there is a congestion or blocking. So that's why to avoid the blocking, that information should be transmitted same data in different another carrier frequency. For this purpose, we are using the carrier frequency and multiple channels. Okay, so there are different ways for different application, different carrier frequencies are used. First part, carrier, okay, for different application, different carrier frequencies are used. That is the first point. Second point, if a particular channel is busy, then that should be transmitted using another carrier frequency or another channel. So next, state change and time energy. Okay, so already mentioned that transceiver is a transmission and also receive. That is a half duplex. So that's why it changed from transmitting mode into receiving mode. So that is called as a state change times and energy. So actually what I'm saying is that sometimes you want to transmit, sometimes you want to receive. So it changed from transmitting mode into receiving mode, then how much energy is required. That is called as a state times, how much time. So suppose the time gap is very less, then it is very efficient. Next step. Actually, sensor can detect only a small amount of data. It is order of 10 kb. It is the order of 10 kb. So that's why the order of data is equal to order of only a 10 kb data. Okay. Next step. What are the modulation techniques are there? So because you are not supposed to always don't follow always the same single modulation technique. There are ASK, OVK, okay, on-off switching king, AFK, FSK. You can use any one. So that's why the transceiver having a capacity to use the different modulation. So next, different coding techniques are there. So according to the application, which coding is best, then you can choose that coding techniques. Okay, next. Next is the transmission power control. What is the transmission power control? Actually, as we have the power, more and more the power, then we are able to transfer. But it is not applicable to every application. According to your application power level, there is a level control is there. So for a single application, you can send with more power. It is not necessary. So there is a control on the power. That is a control on the power levels. So don't cross about the threshold levels. Don't cross above the threshold levels. So that's why there is a control on the transmission or control, right? Noise figure, that is called noise figure. So an element is there having an input and output is there. So what is a noise figure? It is a ratio between signal to noise ratio at the output by signal to noise ratio at the input. So this is called as a noise figure. And gain, overall, what is the gain? So gain is what is the input power and what is the radiated power. What is the radiated? Okay. What is the output is available? That is called as the total gain. So it should be considered. So gain as much as possible. Okay. Next is the power efficiency. So what is the power efficiency? Your rate out is the radiated power. Radiated power. There is a radiated power. First point. Next, within this device, there are certain power consumption is there. So that's why it is a ratio between the power radiated by the individual spending of the power is called as a power efficiency. Next, receiver sensitivity. What is the receiver sensitivity? The power, you already know that as sensitivity less, as the sensitivity less, it can detect a small amount of power. So Okay, right. So next to receiver sensitivity. As the receiver sensitivity, that means for the receiving purpose, the power as less as possible. But it will specify that it will specify that the what is the power required to estimate the bit error rate. 10 power minus 9, 10 power minus 12. So that's why as the 10 power minus 12 means 1 bit error for transmission receiving of 10 power 12. 10 power 12. So that's why the receiver sensitivity should be as less as possible in terms of the bit error rate. Next is the uh, range. Range stands for if your sending signal is more powerful, then we already we know that as a communicating student, we know that as the signal power is large, it can reach the destination long distance long distance without any error. Suppose in ideal condition, suppose there are different combinations of abstractions should be takes place. Number one, characteristics of the antenna. Number two, interference. Number three, power loss, and modulation, carrier frequency, the error rate, and everything should be considered. Everything should be considered. So that's why the range is completely depends upon the your range is completely there are all the parameters. Antenna characteristics, next to radiated power, next to modulation, next to bit rate, and carrier frequency. So we should consider all these things. All these things. Okay. Not only single parameter should be considered alone. Next is the carrier sense. What is the carrier sense? We already studied in the last class in the computer network about that. In the bus structure or whatever it may be, there are so many systems out there. All are connecting a common medium. So at a time I want to avoid the collision, then what can I do? I want to say transmit my data only. Okay, whenever it is a free. Whenever it is a free. If I am sending somebody or another also is placing the data, then there is a collision. To avoid this collision, then what happens? We can use the carrier sense. So carrier sense. So sensing the medium. If it is busy, then what happens? It should be idle for some time until it is a free. Until it is a free. Okay. So you should follow the IEEE 802.15.4. Okay. Right. So this is the already explained in the previous class. Okay. So next one, what is the structure of the uh, transceiver? What is the structure of the transceiver? Actually, transceiver having the two parts. I can show you. This is the two parts. This is called as a RF front end. RF front end. Second one is called as a baseband processing. This is called as a baseband processing. So I repeat, it has the two structure, two parts are there. One is called as a radio front end, and second one is called as a baseband processing. Okay, but in this class I want to discuss about the RF front end parts. Okay, so what is the RF front end and what is the baseband? You already know that. So RF stands for analog. Okay, baseband stands for digital. So that's why it is a combination of both analog and digital. So one can perform the digital and one can perform the analog purpose. So that's why in the RF front end, analog signal processing the actual radio frequency band. Okay, baseband can be used for the digital signal processing in the digital domain. Right. Next to between these two between these two, a mediator is there, a interface is there. That is called as a digital to analog conversion and analog to digital conversion, DAC and ADC. Okay, so there is a boundary between these two. So digital to analog and analog to digital, because they mutual exchange. So for this purpose, there is a boundary is there. That boundary can perform digital to analog, digital to analog, or analog to digital purpose. So this is the basic structure of the transceiver. I repeat, it contains the three parts. One is called as a radio front end. Second one is called as a baseband. Third one is a boundary between these two, a converter is there. Analog to digital, digital to analog, digital to analog, and analog to digital converter. Next. Next. Now I want to discuss about the RF front-ended parts. RF front-ended parts. So let us take what is the RF front-ended parts. Number one, this is called as a power amplifier. This is a power amplifier. So this is a power amplifier, and this until it will satisfy certain power levels, then it can be transmitted to the antenna. Okay. Now, suppose it is receiving that, then what happens? If it is not satisfied, then what happens? Low noise powered LNA. Low noise powered LNA. And this is called as a frequency changes. Frequency changes. Okay. All right. What is the power amplifier? So actually, as shown in the diagram, so it can receive from the baseband. So let us take, this is the receive from the, okay, this is the from the baseband, and it should be amplified. So actually baseband is there, then it is converted into analog, and it is converted into analog, and that signal is very low. So that's why that can be used for the amplifier. So this is called as a power amplifier. Here, right, next. Okay, so that's why the power amplifier can be used for the amplification purpose. Right. Next is the low noise filter. Okay, low noise amplifier. So, so can you read this? Amplify the incoming signal up to, okay, right. So up to level suitable for further processing without significantly reduce the PSNR. So let us take here. Suppose it can receive the low noise signal. So signal, okay, but to require the signal to noise ratio, it should be amplified. It should be amplified. I repeat, it can receive certain low noise signal, okay, and it can be used for the required signal to noise ratio. For this, you can use the TLNA. Okay, right. So let us take, this is called as a local oscillator. I can show you in the diagram. This is the local oscillator. Okay, local oscillator. Then what is the purpose of this? So see this. Local oscillators or voltage control oscillator mixers are used for the frequency conversion. Frequency conversion from R spectrum to intermediate frequencies or the baseband. So the incoming signal at RF frequency is F is multiplied in a mixture with the fixed frequency signal from a local oscillator. So the resulting intermediate frequency signal has to be possible by FLO minus FRF. Okay, so what is the purpose? Suppose if you want to change the frequency, I already mentioned that, already previously mentioned that, but the frequency changing, because different application can use the different carrier frequencies. So there can be changes in the frequency. For this purpose, it can be used in here. Right. So actually, a small part is remaining. Different types of transceivers are there. So in the leisure time, or if time is available, that I can explain you. Okay, right. Because we are always trying to always in the only a few pages from the past 1 week. It is not moving forward, either by my problem or either by student or whatever it may be, some problems are there. So that's why with the cooperation of us, we should move forward because time is very less. Okay, only 2 months is there. Within the 2 months, we want to cover the entire syllabus. So that's why what I'm saying is that please cooperate with us. With the cooperation, then we should move forward. Okay, all right. Next part of our node structure. So up to now we are discussing the transceiver, memory, controller, power supply, and next one is the sensors and actuators. Sensors and actuators. So already you know that sensor. Okay, sensor sense the physical quantity. Sense the physical quantity from the environment. That quantity, whatever it may be, that quantity. So it can sense and convert into a log. Okay, a signal, a signal. That's all. So now this can act as a one switch. Assume that. So sense the signal, sense the physical quantity, and it can produce a signal. Then, according to the signal, then what you want to do, that can specify the actuator. So if the switch is on, then actuator is working. The switch is off, actuator is not working. So that's why for the actuators, sensor is a switch. For the actuators, sensor is a switch. Okay, all right. So now what are the sensor? So already said that sensor is a sense the physical quantity from the environment. So right. It is very not forgettable. End of the class they are joining. Okay, sensors. What are the types of sensors are there? There are primarily two types of sensors are there. Number one, passive. Number two, active. Number one, passive, and number two, active. Okay, what is the passive? What is the passive and what is the active? Passive in the sense of without any change of the environment, without change of the environment, the sensor just detect the physical quantity, and according to the physical quantity, a corresponding signal should be generated. This is called as a passive. Without disturbing the environment, it will just collect the physical quantity and it should be converted into a corresponding signal. Okay. What is the active sensor? So, what the active sensor mean? We are applying some energy. We are applying some external energy. Then, after applying, then what is the change? What is the change in physical quantity? That is called as a active. That is called as a active sensors. I repeat, passive stands for without disturbing the environment. It is just sense the physical quantity and give according to that corresponding signal. Right. Next to active stands for by applying some energy, then what is the change in the quantity? What is the change in the quantity? That quantity should be measured by the sensor. That is called as a active sensor. That is called as a active sensor. Okay, all right. So now in the passive, there are two types of sensors out there. Number one, omnidirectional. 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 So what is the omnidirectional? That means sensing and giving. Sensing and giving. The best example already so many applications are there: smoke detector, temperature detector, humidity sensor, so many sensors. So just it can just detect enough. Okay, there is no directional. It's what is detection. Okay, and narrow beam sensor, so that will give some direction. It will give, okay, it will have the narrow range. Okay, so in the particular one it can be detected. So that is there is a direction. Okay, next. What is the important thing is that area of the coverage. What is that area of the coverage? Area of the coverage. What is the area of the coverage? Um, suppose that it is, what is the function of the sensor? Sensor can detect the physical quantity. Sensor can detect the physical quantity, first one. So that physical quantity, how much distance? Very near or very far or whatever it may be. Okay. The best example I want to give, temperature. Temperature. So what is the temperature? Temperature, if it is very near, then it's a high temperature. As it passes, then the temperature gradient is there. So that means there is a decrease in the temperature. Okay, so that's why, so to measure all these things, not only for a particular distance, it can be covered a particular area, a particular radius or particular area around the sensor. So that is the area of coverage is important. If the area of coverage, then what happens? It can detect every sensor. So that sensor can detect the area of range. Then it will average should be takes place. Then we will get the exact value. Exact value. So that is the area of coverage is also important. Okay. Right. Okay. Next. So sensors already explained. Actuators already explained. Types of sensors already explained. And what is the primary thing is the area of coverage. Next is the power supply. Because for operating of the any sensor, any device, you require the power supply. We require the power supply. So that's why what are the power supply for the sensor nodes? Power supply for the sensor nodes. Okay, number one. So two aspects are there. The first one, power can be stored. Power can be stored. Whenever you require, you can utilize or consume. This is general normally. This is generally normally can be performed. So you can power is there. Okay, that means you can just buy a battery having energy. So you are using the battery as you are utilizing. Then what happens? The energy should be decreases. The energy can be utilized for the application purpose. This is the first one. Second one is that suppose your energy is losing. Your energy is losing. So, but I want to fulfill that losing energy from the external energy source. That is called scavenger. That is called as a scavenging batteries. What is the scavenging? It can be extract, losing energy from the outside to fulfill every time it is a full. Every time it is a full. Okay, so that's why there are two types of power supplies are there. Number one, you should first store the energy, and that energy can be used for the required form. Second is the scavenging power supply. What is scavenging power supply? If the power is lost, then loss of power can be grasping or scavenging from outside energy source. From outside energy source. So this is the second. Next. So how to store the energy? So there are two types. One is uh, chargeable energy and re-energy. So that means by recharging, then it should be energy should be rechargeable. So rechargeable batteries are chargeable normal batteries. So the traditional batteries are there. They're non-rechargeable and rechargeable. So normally our batteries are there. Our batteries are there. Sometimes we already know that. So chargeable, non-chargeable. So, okay, you can use any one. So next, are the power batteries can be used for the sensors. So first thing is the by observing this table. So for the primary battery, what is the primary battery? It is a non that is a non-rechargeable. So this is the primary battery, and secondary batteries is the rechargeable batteries. So primary batteries are the zinc 8 batteries. So its energy storage is the 3780. So joule per centimeter cube. Okay, its strength is joule per centimeter cube. So actually by observing there are three different types of batteries are there. So out of this we can always choose the highest one. Okay, this is the first one is called as a non-chargeable and this is the rechargeable. Okay, what is the battery characteristics? What are the battery characteristics for the sensor? Okay, the first one, the capacity. The first one is the capacity. So as your requirement, you want to more energy or less energy always? Obviously more. So for more energy, then what you can require? It requires a wide area. A wide area. So that's why we go to the previous slide. So then this is called as a wide area. Imagine this is the reference purpose. So zinc 8 is a more wide area rechargeable battery, non-rechargeable battery. So that's why we are preferring zinc a more wide area non-rechargeable battery can be preferred. First one, capacity under load. What is the capacity? Suppose sometimes you require more energy consumption. Sometimes you can less energy consumption according to your application. According to your application. Suppose some require more energy. So that's why according to your load, according to your consumption, you should supply the data. You should supply the current. You should consume the energy. Okay. But next is the self-discharge. Self-discharge. What is the self-discharge? Suppose you are buying one battery after, but he is giving a guarantee for 1 year. But after one day it is totally lost. Total energy is lost. So then you are not accept that. Actually, the discharging of the energy is as less as possible for the more utilization. Plus, for more utilization, the discharge is as less as possible. So that's why the battery should be self-discharge. And that discharge is very less. Very less. Next to efficient recharging. Efficient recharging. Already says that the scavenging batteries. So that can be recharging. Loss of energy can be recharging. Okay? Next is the relaxation. Relaxation. What is the relaxation? Suppose we are expecting that single battery is sufficient. We are expecting that single battery is efficient. But what happens is that suppose if the battery is totally consumed, no charge, no charge, then what happens? Your sensor is not working. So that's why instead of single battery, you should use the multiple batteries. You should use the multiple batteries, and for the multiple battery, you can schedule. You can schedule. Suppose first battery, next battery, next battery, next battery. For this purpose, what happens? You can your operation should be considered and without any disturbance. Right. Next is the DC-DC conversion. What is the DC-DC conversion? So that's why I'm saying that. Suppose if your energy is more, if the energy is more, that is battery energy is more, then you are working very efficiently. So as goes on, energy decreases. Then the corresponding voltage supplied to the sensor is low, decreases. Energy, high voltage is supplied to sensor. Low energy, as the energy decreases, then what happens? The corresponding voltage applied to the sensor is decreases. So the sensor is incapable. Certain application. So that's why what happens is that to continuously supplying the same voltage, continuously supplying the same voltage to the sensor, then we are using the DC-DC conversion. It can extract all the energy from the battery and that energy corresponding voltage. So that means what happens? So the DC-DC conversion, what happens is that it can supply the constant voltage by extracting energy from the battery and keep on the total voltage is constant. But the consumption is very fast. The consumption is very fast. So that's why DC-DC conversion sometimes utilizes, but the main drawback is that the consumption is very fast. So why? Because all the energy can be converted into the required voltage. So that's why what happens, DC-DC conversion can be utilized, but the power consumption is very fast. So this is some idea about the sensors, actuators, and what are the battery characteristics used for the sensor. And remaining should be discussed in the next class.